see this problem essentially is the same thing. We want to first of all move the x squared and x to the same side of the equation, and then we're going to use those two parts to complete the square. So I'm going to make my square. I've got my x squared to start my square. I need to symmetrically distribute my middle term negative kx. So I'm going to put half of it here, half of it over here, and then I can complete my square. So I can see that I need a coefficient of negative k over 2, negative k over 2. And so taking half of the middle term and squaring it, I'm going to get k squared over 4. So negative k over times negative k is k squared. 2 times 2 is 4. So once I've completed my square, I need to make sure I balance my equation. And then I'm going to write the completed square in its factored form. So x minus k over 2 all squared is equal to 1 plus k squared over 4. I've now got my square form. I can undo the square to solve for x. So I get plus minus 1 plus k squared over 4. And then solving for x, I get k over 2 plus minus the square root of 1 plus k squared over 4. Again, that's good enough. I can put this in another form by just recognizing that that denominator of root 4 matches a 2 here. So I'm just going to get a common denominator inside the root. So 4 plus k squared over 4. Make sure you don't square the square root across the plus. We don't get 2 plus k. We can never square root when there's a plus there. And then solving for k, we're just putting it in the common denominator. I get 4 plus k squared over 2. And then I can just write this all over the common denominator of k plus minus 4 plus k squared all over 2.